Welcome everyone in the subject urban and suburban transportation concept and strategy. Today we will try to understand that how we can increase the transit speed. So the increase of transit speed is one of the most effective way of increasing the attractiveness of the transit for the travelers. Most of the transit systems are suffering from the low speed from the lower speed, despite the fact that a lot of huge capital amount is already spent or invested on that. Most of the transit system they have a adequate speed for a short to medium distance trip. However, for the longer trips, they cannot maintain the same speed. So the requirement for the speed is higher, while the desire to increase the transit speed is becoming one of the most increasing challenge in problem. Challenge for the designer, while the increase in speed is the requirement from the travelers. In today's session, we will try to understand that how we can increase the transit speeds with the stopping regimes and different stops. Keep in mind in this session, you need to think as a designer, okay? You need to think as a strategic transportation planner so that how you can increase the transit speed. First of all, to go in a detail, you need to understand that what are the existing barriers within your city, within your proposed transportation system. Good street design for a transit requires two things. Number one, to have a balanced relation between the serving population as well as for the and also to provide the mixed used concept as well. Travel times is considered as one of the most important factor while choosing any type of a transit system. If it's a rail, if it's a rapid mass system, if it's a metro, if it's a BRT, etc. Okay, because here you need to think as a planner that how you can uh, encourage the traveler not to use their personal vehicles while to shift to the public transit system. In today's session, we will try to understand that how we can increase the transit speed, such as what we need to design within the vehicle and how we can increase the performance and how we can design the intersection. We will also try to understand that how we can prioritize the signal if the same transit system is crossing any intersection, how we can give a priorities to that specific transit system and how we can improve. Okay, those are the some of the measures which we will try to understand a bit in a more detail. Okay, moving on to the very first one, vehicle design and performance characteristic. As you can see here, the interior design is very much important because if the aisle is a bit narrow, so we might have an issue in the alighting and boarding of the passenger because the circulation may cause delay and stop if the aisle is narrow and passenger is uh, is a bit more heavy and they need to alight and board. So in that specific situation, to increase the alighting and boarding capacity, we need to eliminate the seats, the chair which are near to the door. This is one of the measure which we can do within the vehicle to improve the alighting and boarding. Because keep in mind, we want to increase the transit speed. For example, if at any particular station, the vehicle might stop for more than 1 minute, and it's supposed to stay there for like 20 to 25 seconds so that they can easily alight and aboard passenger and then it move on. So this 30-second delay is it is single particular stop. In the same way it goes on. The second is we need to introduce the low floor buses because installation of a low floor vehicle usually offer more faster and easier boarding and alighting facility. And the third one is about the operation on the street maps. Okay. Uh, Most of the vehicles you need to consider if they are the electrical powered vehicles or the buses or engines with more stronger motors or special gearing system because we need to achieve a speed at a certain gradient, at a certain steep. Its best example is Peshawar BRT because in most of the cases it's supposed to go at a speed of a 60 km per hour. But the issue is if those steep gradient, the bus cannot maintain at least like not more than 40 km per hour. So you need to understand this reduction of 20 km per hour in those steep gradient so that how much we can increase the travel time. And the third concept is about right of way. Of course, if the same bus is operating from the right of way category C, that will attract less passenger and will have less speed and it will have longer travel time. And then we have, if for example, if we would like to compare it with the right of way category B, which we consider is most of the time metros or like rail lines, etc., and tram lines, so they have a bit more area coverage is compared to right of category C, and they can maintain higher speed as well because they only share its path at the intersection. How we can increase the transit speed if we would like to see any particular street design. As you can see here, the intersection design should have the precise channelization, which will conventionally located transit step such as turning lanes, pedestrian control, and protection lines, and so on. As you can see here in that specific map, which is shown in that specific slide. So the bus will enter from here. It does not have any fixed barrier at the very top, and then it can move on. Okay. In the construction of bus bulb, this the specific concept called bus stop bulb out. Okay, so here it can go on, and then it can goes out, and also in the next slide, I will show that how we can eliminate the curb parking as well. As here you can see here, when the vehicle will stop here at its specific location, which is a quite dedicated bus stop. But the only issue is that the same bus will go on, for example, when it stops, so that will stop it exactly in like that place. So to move on, it need a lot of distance. So in that particular section, we can also introduce the same old concept, bus bulb concept as well. Okay. The purpose to provide such type of a services so that it should not have the barrier, so which can reduce the speed and also make it more hard for those driver to take the turn from that specific curb or which you call the kind of obstacle. This is one of the typical example that how we can bring right of way category B and C. This is from Munich, Germany. As you can see here, they have a quite narrow street where the tram is also moving in like both directions. The car is also using the same line, and the buses are also use it. But those buses does not have any kind of a man-made obstacle which can reduce its speed. So it's directly goes. goes on. Okay. And they have also, you can see here, parking at your right hand side. So you can call that the single figure, which can hold all the right of way, all the priorities in each and everything in the same package. This is one of the typical example. One is from Beijing, Shanghai, from China, while the down one is from the Munich. As you can see here, they have the kind of a elevated bus stop, okay, which does not have any barrier at the front as well as at the back side, so it can directly comes in and then directly goes out. The next topic, that how we can increase the transit speed, is about the traffic signal priorities. So here you can see that we have the optical or mechanical detector are installed at every crossing, which only detect and pass its signal through controller, which is installed within that specific transit mode, and which emit the signal, and that optical detect the signal and it send request to the controller that give me the priorities, so that I can move on. I can, if there is a kind of a fixed or timed signal which is installed about 60 seconds. So if the same vehicle send its message, so it can move on easily. In the next figure, you can also see that we have different optical detector are installed in different sections, because if you can see here, so if this is a distance for about 200 or 300 meter, so when it will detect or pass its signal to the controller, so that will start changing of that specific signal, which will allow those vehicles to move on. So traffic signal priorities, which includes the early green, extended green, the different phase sequence change, or special phase activation, and also the absolute traffic signal uh, could also be possible. As you can see here, the above we have all the theoretical part, while in the below picture you can see its applied form. So we have a specific signal for those buses, for the pedestrian, as well as the vehicles are only allowed within specific sections. Okay, so those are the parameters through which we can give priorities to the transit, either tram, either railway intersection, or either the BRT as well. Okay, at any particular section. The next point is about that how we can increase the different elements exist within transit operations. So its first one is about the faster fare collection. Faster fare collection, or the manual payment by the passenger when they aboard at any particular street transit vehicles, which have a best slow fare collection method. The second is we can also replace the cash with different tokens, and which can also provide and also encourage those rider to have the multiple ride tickets, weekly system, or monthly passes as well. Even you also need to encourage the mobile payment as well. While the third one is how we can change the route layout to eliminate if we have any excessive turns. The same was done in Pakistan Railways. So the distance from Lahore to Pendi was reduced for about, before it was 5 hours 30 minutes, and now it's almost 4 hours. So 1 hour 30 minutes were eliminated, while only to reduce those zigzag lines. Okay. And also we can talk about the skip stop and zonal system as well. Uh, you need to understand that in any particular transit, we have the two different regimes of the stop. Okay, the first one is called demand stop. The second one is called on-call stopping, while the third one is called fixed stopping. We will start from the fixed stopping. In any transit unit, which will only stop regardless if there is any passenger would like a board or a light, but that will stop over there for a fixed time. For example, from 15 to 20 second or 30 second, unless and until the same driver, if he did not push those opening buttons of the transit unit, it will maybe kind of a give the kind of alert sign from the control station. The second way is about on-call stop. So those are the fixed type of a stop location where the transit unit stops only where there is a passenger demand. And the demand stopping is when you are sitting within transit system, it will move on without opening and closing of the doors. But if you push there the demand button, which is most of the time paved or marked in the yellow or red form, almost with every seat, so then it only stop at that demand stop at any particular stop. You can see here demand stopping, and then we have on-call stopping. For example, in the on-call stopping, so if here at this station number 2, we have the demand from the 3 people, so it will only stop here. But if those 2 points did not mention any demand, it will directly move on, okay, and so on. In the fixed stop, it will exactly stop at each and every location. If the passenger would like to board or alight, but that will stop over there. And the demand stopping is only where, for example, if the same stations, 10 station, if we have only demand from those 4, so it will only stop over there. How we can increase the rail transit operation? Okay, so this was all about it, what we can do or how the demand and stopping regimes work. Now we will try to understand the 3 basic concepts which is applied in most of the transit system of the developing and underdeveloping and all the developed countries as well. Those 3 best system is New York subway system and the skip stop and zonal stop are the skip stop in the combination of express lines. Its best example is from the underdeveloping or the third countries is Pakistan as well, where the Peshawar BRT also work on the same concept. Now we will try to understand that how those different system works. As you can see here, the train A, this is a typical example of the skip stop and zonal stop in the express trains. So the train A only stop at the any particular stations. For example, first and then third and then 7th and then 10th and then 11th. And the same B also stop at any particular stations. So like which is marked with B, okay? A, B, and then A, B, and then B, and then B, and then B, okay? So this is the same route which is followed by the 2 different trains for the purpose. For example, if you are in the train A and you would like to reach to like that point, so you can imagine that you eliminate point 1, 2, and 3 to reach to that location. Similarly, is a case with the point B as well. If you want to reach here, so you also eliminate point 1, 2, and 3, and you can reach here as soon as possible. Okay, so this is the typical example of the skip stop. Skip stop means when you skip some stop and reach to your locations. Okay, the third one is about the zonal operation. The zonal operation means that the same route is again divided in different zones, and each zone is covered by the different trains. For example, this one is controlled or covered by the zone 1. This is covered by the zone 2. This is covered by the zone 3. And then we have the express and local trains. Local means which is quite clear from its name. It will stop at each and every stop. And in the express form, it will only stop at the few locations. So those few locations are most of the time selected on the basis of the attractiveness. For example, if you ever took the route of BRT in Peshawar, Pakistan. So from the Mall of Hyderabad, when it goes to the Peshawar Sadr, so it's only stop at the Islamia College and then at the at one station again. So it will take you directly with the two station while skipping almost 5 to 6 different stops directly to Peshawar Sadr, because most of the people from Hyderabad, they would like to go to either to Peshawar University or directly to the Peshawar Sadr. Okay. This is the skip stop operation, how it looks like. This is of the line 2, 4, and 5 from the Santiago, Chile metro lines. As you can see here, we have the different routes are located with different signs, like 2, 4, 5. It's the red is only 2, while a bit sky green is 4, while the one which have the white inner circle background is 5. So as you can see here, different routes operating and stopping at different locations. Okay, so this is the typical example of the skip stop. Again, if you like to understand that the skip stop is again the only type of operation by which operating speed on transit line with only 2 tracks can be increased while maintaining higher frequency and high line capacity. As you can see here, the if we have the two different lines and we divide those stations in the with respect to time, so it will reduce the time, okay, to reach to any particular station. Skip stop can be obtained when we classify those different locations, such as here we have the 3 different line, A line, B line, and then AB lines. Okay. The main functions or characteristic are why we provide skip stop, because it have number one, the higher operating speed, because it stop at different location for some time. Sometime it stopped and sometime it did not stop. So it have the higher operating speed. Okay. It have the more productivity of the transit units, because we can imagine and the 100% utilization of the available seats as well as of the capacity, which will also reduce the cost of operating of any particular transit unit. Okay, and overall the capacity of the same line will also be not affected. Okay, skip stop also a bit require special mail function, technological function, but it does not require any investment. So you can, this is only the to like bring the concept of 3 different lines to the single line to increase its speed, operating cost, reduce operating cost per passenger, and also the important thing is to increase the transit speed. Okay, so this is the concept of a skip stop. The next point is about the zonal operation. Zonal operation is obtained when the same line is divided into 2 or more sections, as you can see here. So this is a zone 1, this is zone 2, and this is zone 3. In each zone is served by a different set of the trains. Okay, and zonal operation can only be used when we have the longer radial lines, means which have the large majority of the passenger who would like to go in any of the central business CBD area, central business district areas. And to achieve that type of services, a huge interchange ability of trains among different zones. We need to design our stations to hold that more number of the passenger volumes. Okay, so like those all 3 trains move on, but three most of those 3 are actually divided in the different zones. In each zone is covered by different trains. Thank you very much. If you have any question, you can get back in the comment section.